Hi everyone, with Calvin here. So let's discuss about Weekly Contest 9, third question. Find smallest common element in all row. So we are given a matrix mat, and then every row have sorted increasing order, and we're being asked to return the smallest common element in all row, and otherwise we return a -1 if there is no common element. And take a look here on the first example. So we have 4 row here, and each of the row and we can notice like 5 is our smallest common element, and notice we have smaller elements such as 1, but it's not exist in all row, so it's not valid for smallest common element. Only 5 is exists in all row and it's the smallest one, so we return a 5 in that case. So how are we going to solve this question? So if we're going to scan through the entire array, it will cause a timeout. So we need a more efficient way to do that rather than we scan through all the element. So yeah, the way to solve it is by doing a binary search. So the binary search is to find find the value of at least. So find at least for example, in the first row, we're going to find a value that at least 0 and it's the smallest one, so we will return 1. And let's say on second row we try to find a value that is at least 7 and it's the smallest one, so we will return an 8 in that case. So we can do that by doing a binary search. So here we have a method called find at least of the target A inside the data itself. So we do a binary search from low to high. So if the data is equals to the A, we return the A itself. But if the data is larger than A, then it might be our candidate. So we mark the high equals to mid. But if the data itself is smaller than A, it means it cannot be our candidate. So we mark the low is equals to mid plus 1 because the mid itself is not the candidate of at least A. And at the end, we return the data on the index low to find at least. Notice that this function might return something that is smaller than A. For example, on the first array, I asked to find at least 6. So in that case, I will return until 5. Okay, because 6 doesn't exist, so 5 is the best effort we can get from the data low. So we're going to validate that extra case in the following function. So when we do a smallest common element search, maximum is our expected output. So I name it max, but initially I mark it with the minimum value. And then after that, we need to loop through our entire row, like all of our row. So if we find at least maximum, okay, equals to minimum value, so we find a value that is at least this value. So if the value is itself, it means that max is a valid smallest common element, because in current row we also have that value, right? So I increment the total. But if we find a value that is larger than the max, it means it's not the smallest common element because it doesn't exist, so it's returning us a larger element than the smallest common element itself. Okay, so instead we reset the total into 0 and then the max equals to result, because in this row we don't have that value as smallest common element because we find a bigger one, so we mark the bigger one as the next candidate. But if the candidate is smaller, which the case I explained, like 1, 2, 3, 4, 5, and we try to find the candidate of at least 6, it will return as a 5. It means there is no candidate exist anymore, so we return a -1. And if all the row have the result of find at least is equals to our smallest common element, then we return our smallest common element as the answer. So yeah, that's it for this question. Thank you for watching. See you on the next weekly contest.